My name's Lee Hamlet. I'm with Yokogawa. I'm a product manager. I've been here 12 years. Well, pressure is very simple. It's just the amount of force applied over a certain area. This can apply to gas, liquid, anything that applies a certain force over a certain amount of area. Well, pressure is one of the 4 unique measurements inside of a plant. The others being flow, temperature, and level. But what's unique about pressure is pressure can actually be used to infer the other 3. Flow, by using a pressure transmitter across a venturi, a pitot tube, or a orifice plate, you can infer what the flow is of the gas or liquid that you're measuring. With level in a tank, you can use the hydrostatic head pressure principle to measure the amount of liquid in a tank. And then last, though not used very much, is using pressure to measure temperature. That's where you have a certain amount of gas in an enclosed area, and as the temperature changes, the pressure inside the chamber changes, and by the change of pressure, you know what the change in temperature is. Well, there's 3 attributes that are important. The first is that in a chamber, the pressure is the same no matter where you're located inside the chamber. So whether you're at the top, the bottom, the left, or the right, the pressure is the same no matter where you're at in the chamber. The second attribute is if you have the same amount of gas in a chamber and you change the size of the chamber, the pressure changes in the chamber to meet the size you've changed to. So if you make a smaller chamber, the pressure goes up. If the chamber gets bigger, the pressure goes down. And the third attribute is the way that temperature affects pressure. If you have a given size chamber with a gas in it and you increase the temperature, the pressure will increase in it. Or if you decrease the temperature, the pressure will decrease. And those all 3 are very important to know. Well, when you measure pressure, what you're really doing is comparing 2 pressures to each other. And there's a couple ways to qualify that. There's a gauge pressure measurement that compares the pressure that you're measuring to the atmospheric pressure. Now, that's very similar to what you do with your car tire. When you measure the pressure in your car tire, you're actually comparing the pressure in the tire to the pressure outside of the tire. Problem with that is if there's any change in the local pressure, it can look like your accuracy is off. And pressure changes when a thunderstorm comes through or a cold front or anything like that. The local atmospheric pressure can change. Now, the next one is, of course, absolute pressure. And that's where you compare your pressure you're wanting to measure to absolutely 0 pressure. Now, of course, 0 pressure doesn't exist anywhere. So it's very hard to build a transmitter that references. You have to suck the vacuum out of a chamber to compare it to. And that's very good because it doesn't have the variation that you get with gauge pressure. Problem is they're very expensive. So some customers will put up with using a gauge reference since it's less expensive, or instead of the absolute pressure, which is more accurate. Then there's also just a differential pressure reference, and that's where you're just comparing 2 pressures. Those pressures are not necessarily local atmospheric pressure, they're not absolute pressures, there's just 2 separate pressures that you're comparing to each other. Well, you use a pressure transmitter. Pressure transmitters have sensors in them that are designed to measure the pressure. And how they do that is they have a physical attribute in the sensor that changes when pressure changes. So you're actually measuring the change in that physical attribute to infer what the pressure change is. There's several different ways of doing that. There's sensors on the market that use frequency, there's sensors on the market that use capacitance, there's sensors on the market that use inductance. But there are all kinds of sensors out there, and you can find transmitters that use all the different technologies. No, the transmitter takes the information from the sensor and transmits it or communicates with something else that needs the information. That can be a controller, a DCS, or even a cloud-based data collection program. What's important is that the transmitter do it quickly, reliably, and accurately. That's what's important. Well, most transmitters are hardwired to whatever needs the information, but there are also wireless solutions out there that broadcast the information to where it needs to go. Well, there's two different ones. There's an analog communication and there's also a digital communication. And you can have either the analog or either the digital or a combination of the two. With analog, you have a 1 to 5 volt DC or a 4 to 20 milliamp signal that corresponds to the variations in the pressure. With digital, you actually have a protocol. And that's a language that the controller and the transmitter can speak with each other to get the information. Some popular ones that are out there are HART, there's also Field Bus, there's Modbus, there's a whole host. Some companies even have a proprietary communication that they use. So there's a lot to choose from out there. Just make sure that all of your equipment speaks the same language. Well, as we discussed before, you want your transmitter to quickly, accurately, and reliably get the signal to where it needs to go. Unfortunately, with a lot of pressure transmitters out there, the specifications that convert to these qualities are hard to understand. When it comes to quickly, you're looking for response time. You want a fast response time. When you're looking at accuracy, that's easy. That's usually referred to as reference accuracy. But the one that comes a little hard to understand is reliability. And that's usually contained into a specification called stability. So what you want to look for is the response time, the accuracy, and the stability of the transmitter you're looking at. Well, all applications and all pressure transmitters are different. All sensors, all manufacturers, everybody has their strengths and weaknesses. You just need to evaluate what your application needs and pick the unit that best picks or best suits your application. Well, a good source of information would be yokogawa.com/US. There you'll find these questions and the answers and other things that you can use to help you evaluate transmitters.